Alright guys, so you guys are welcome to today's class. So quickly we'll be talking about the distance between 2 points. Okay, so these are just the things we'll be talking about in this class. First, we'll be looking at the distance, how to calculate the distance between 2 points. How to calculate distance between 2 points. So I want you to pay attention, get your notes, and make sure you take relevant notes. Okay, so we're having distance between 2 points: speed, velocity, and acceleration. And lastly, we'll be looking about velocity time graph. So at the end of this class, I am expecting the whole of you to be able to effortlessly calculate the distance between 2 points. When you have 2 points on a plane, how do you calculate the distances? So that is what I'm going to be teaching you here in this video. Okay, so and also at least from at the end of this video, you should have a knowledge of speed, velocity and acceleration, and how to perform simple calculations under them and then velocity time graph. So quickly, without wasting much of our time, let's just get to the first lesson number, which is the distance between 2 points. So let's say we have 2 points like point A and B on a plane line. Let's say we have these points. First of all, let's draw this. Let's say we have these points, point A and point B, point A and point B, point A and point B. Now let's say we have these 2 points on this plane. How do we calculate the distance between these 2 points? Remember, if you pay attention to the video, the previous class, I explained something relating to this, how to locate a point on a plane. Okay, I told you just to draw a graph like this, and then we have this place to be our origin. Of course, this is our y-axis, and this is our x-axis. So how do we get the distance of these points, knowing these points that are located on this plane? Now it's very simple. Now look at this. If this point 0, if we trace this point down to this side, all right, the point where it meets this y-axis, you can call it y1. So it means from here to here is y1. So if you trace it down, this will be what? x1. On the horizontal axis, you have x1. On the vertical axis, the point where it meets the vertical axis, that's what we are calling y1. So the same thing, if you do this, if you trace this point downward, if this is x1, we can call this one x2 on the horizontal x-axis. Why this one? We call it what? y2. So remember, we are trying to get the distance between point A and point B, and this is the straight line that connects these 2 points. In other words, we are trying to get the length of this straight line. The length of this straight line. Let's call this straight line AB, line AB. So how do we get the distance between this point A and point? How do we get this length AB? It's very simple. Now, seeing that we have already gotten our x1 and x2, how did I get my x1? I trace from this point, I trace it downward. The point where it meets with the horizontal axis, I named it x1. Why this point B? I traced it downward. The point where it meets with the x-axis. Remember I said this x-axis, you also call it abscissa. In my previous lesson, I made mention of abscissa. So we have this place to be x2. So if we have this to be x2, now look at what I want to do here now. Look at, if I join this line, I complete this line. You see, we are now having a right angle triangle up here. We're having a right angle triangle up here. This is a right angle triangle. And because it's a right angle triangle, let's see if we can get the length of this place. Okay, if you can get the length of this place, it's still the same as the length from here to here. So now look at what I will do here. Look at what I will do. Remember, from here to here is x1, and from here to here is x2. Listen now. From here to here is x1, and from here to here is x2. Now the question is, what will now be from here to here? From this point to this point. If from here to here is x1, and from here to here is x2. Now look at this. Pay attention. It's as if I am asking you. Okay, let's take this line for instance. So I'm like telling you that the length of this small portion is 2 centimeters, and the length of everything is 10 centimeters. If everything is 10 centimeters and here is 2 centimeters, now the question is, what is this place from here to here? Is it not to cut this part out of it? If we cut this part out of it, we are left with what? Only this portion, and the length of this portion will not go. That is everything minus this part. That will give us 8 centimeters. So that is the same idea I'm applying here. From here to here is x centimeter, and from here to here is x2. From here to here is x1, and from here to here is x2. Then from here to here will now be what? The whole of this minus this part. So this place, only this portion will now be x2 minus x1. And if this is x2 minus x1, it means this place is also x2 minus x1. Are you getting what I'm saying now? If you are getting, just put down I am getting it. Now look at this. The same thing I did in this x-axis, I want to apply the same thing here to get this length. This length. If I apply the same thing here, now look at it. From here to here is y1, and from here to here is y2. If from here to here is y1, from here to here is y2, it means from here to here will now be what? y2 minus y1. So we now have this place to be what? y2, and you know this length is still the same as this length here. So what I have here, I can represent it here, y2 minus y1. Please let us bring out this right angle triangle. This right angle, let us bring it out separately. If we are bringing it out, we are having something of this nature. We have something like this. This is y2 minus y1, and this is x2 minus x1. That is this side, this is it. This side, this is it. And we have this A and B. We are trying to get our AB. Okay? Now, if you apply Pythagoras rule here to get this place, Pythagoras rule, you know Pythagoras rule say that in the right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides, that is the opposite and the adjacent. So if we are having applying Pythagoras rule here, we now have this to be AB square equals to square this side 2, that is square this side, y2 minus y1 all square according to Pythagoras rule, plus what? Square this side 2, x2 minus x1 all squared. So if we have this squared, now remember we have to cancel this square from here. You have to square root both sides. This cancel this, so it means our AB, side AB, is equals to what? Square root of y2 minus y1 all square plus what? x2 minus x1 all square. Now this is the, we have gotten a formula now that would help us get our that will help us get the distance between 2 points on a plane. Now look at this. Look at what x was taking me. Remember this point, I was teaching you how to find the coordinates of a point. If you find the coordinate of this point A, the coordinates of point A will be what? What is x? If you trace it downward, we're having x1 here, be x1, comma. If you trace this point down here, you have what? y1, y1. These are the coordinates of point A. You're having this point A to be what? x1, comma, y1. The same thing here for point B. Let us just trace the coordinates. Point B, if you trace it x, I told you usually write the x portion first. You have x2, comma. If you trace it to this side, you have what? y2, point B. Okay, so now the question is, if we are asked to find, let's take example, x and y, that is respectively simply means this first coordinate is for x and the second coordinate is for y. So we're having our x coordinate to be equals to what? 2, 1, and our y coordinate to be equals to minus 1, 4. So how do we apply this formula now to solve the distance between x and y? So it's as if if I'm to draw the diagram of this, I would have something like this. This place would now be my x and this is my y. They are asking me to find the distance between x and y. But with this diagram, we have already coined out a formula that will make the work much more easier. So all I need to do now is to bring out the formula. Remember the formula is what? Since we are talking about xy, it will now be xy, the distance between xy, because it was square root of y2 minus y1 square plus what? x2 minus x1 squared. Since this is the formula, all we need to do now is to substitute the respective values of x1, y1, y2 and x2 into this formula, and then we'll get the value of x1. So how do we do that? So let's begin. Our xy equals to, sorry, the way I'm writing, I believe you are following. Our xy, length xy is equals to what? That is distance between x and y is equals to square root of. Now, what is our y2? If we do comparison, now look at this place now. Y2, look at it. Y2, from there, you have, this is x1, y1, and this is x2, y2. This will now be our what? X1, y1, and this will be x2, y2. So if we are substituting into this formula, wherever you see x1, put the value, and wherever you see x2, put the value, wherever you see y1, put the value, and wherever you see y2, put the value. That's substitution in mathematics now. Now, if we are substituting our y2, if we compare here, our y2 is what? 4. So we have to put our 4 here. 4. Our y2, if you compare here, y2 is 4. So you put 4. Remember there is square. Okay, there's no square. So you have minus, there's bracket, minus. Our y1, this is y1. So what is y1 here? y1 is 1. You put 1. Remember you close your bracket and put square, right? Plus, what about this? You have x2. What is our x2 here? Our x2 is minus 1. So it means you put minus 1 plus, what about our x1? Our x1 is, what is our x1? Our x1 is 2. So you close it and put square there. So what is length xy? If you do this mathematics, 4 minus 1 is 3. So it means we have 3 square plus what? Minus 1 plus 2 will give us what? 1. 1 square. Put 1 square. So what is our final answer? Means our xy, length xy is equals to what? Square root of, if you square this, it gives you 9. Plus, if you square 1, it gives you 1. So you have this to be equals to square root of 10. Square root of 10. If you press a calculator, whatever is your answer, leave it there. Okay? I can choose to leave my answer as, because 10 is not a perfect square, I can choose to leave it like that. But there's no way you can actually simplify 10. Except you want to leave your answer in decimal form. And if you press calculator, you get the answer in decimal form. Now, that is 10. Root 10 is simply the distance between x. This is our question. Between x and y. So you just to apply this formula and then you're going to go. I will do one more example, then give you your own work. If you don't understand the first one, I'm going to give another example now that will help you understand it better. Okay. One beautiful thing is that the more you solve examples, or the more you solve questions, the more you solve problem, the more you understand a particular solving and a particular calculation. So we're going to be doing one more. I believe with that example you understand what we've been discussing. Now is another example before us. We're expected to calculate the distance between these points P and what? Q. The coordinate of P was given and the point coordinate of Q also given. I told you there's a formula. I've already shown you how the formula was derived. Okay, I love the formula was derived. So all you need to do is just to apply the formula. Remember, our formula is PQ, the square root of y2 minus y1 square plus what? X2 minus x1 square. Now this is the simple formula we applied, and all you need to do is just to substitute their respective values. Remember, this place represents what? Our x1, and this is what? Y1. This is what? X2, and this is y2. So substitute it to this formula. You have this to be equal to square root of, what is y2? Our y2, from this place it is 4, minus, what is y1? Y1 is 3, squared, plus, what is our x2? X2 is what? 4. What is our x1? X1 is 5. Close it, square. Please don't forget anything. You can see the way I apply the formula, right? How I did my substitution. First of all, you can just label it like this so that you will not be confused. This first one is x1, this one is y1. Y1 is x2, this one is what? Y2. Just substitute everything, the values into this formula, then you have this. So if we solve this, you have it to be equal to 4 minus 3 minus 1. Remember there is square, plus 4 minus 5 will give us what? It will also give us minus 1. There is square, right? So we have this to be equal to what? If you square this, if you square our PQ, it's equals to, if you square this, square of minus 1, that is minus 1 times minus 1, that would give us 1, plus the same thing here too. If you square minus 1, it gives you 1. So we have PQ to be equals to square of, this is 2. So you can leave your answer like this, square root of 2. That is your answer. But if you press calculator, it will give you, if you press calculator, you get your answer, it give you 1 point something something. That is your answer. I want to believe you understand it now. So if you understand it, do this for me. Do this for me. Calculate the distance between let's say A with coordinates 1 and then minus 1, and B coordinates between point A and point B with coordinate 2 and 2. So I believe you can do this for me. Do this and put your answer at the comment section. Okay, quickly, we're going to be looking at the other part of this lesson, which is speed, velocity, and what acceleration. Remember, I mentioned that we'll be looking at velocity time graph. Okay, if you do not understand the concept of speed, velocity, and acceleration, velocity time graph would be very difficult for you to handle. Okay, so that is why I'm taking my time to set the foundation by explaining these core terms in motion, which is speed, velocity, and what and acceleration. So please pay attention so that I can explain this, and take note of the formulas I'll be giving to you, because they are actually very important. Okay, the formulas I'm giving to you are very important if you will understand motion generally. So now speed, the first one is speed. Speed is simply the distance over time. Please take note of it. Speed is distance over time, and because speed is distance over time, the units will not be what? Meter per seconds. Meter per seconds. The unit of distance is meter, and the unit of time is seconds. So this is meter per second. So you have it like this. This is how you represent it. The same thing for velocity. Velocity is displacement over time. Okay, it has the same unit as your speed. So if speed is meter per second, it means velocity also will be what? Meter per second. And now somebody will not like, okay, what is now the difference between speed and velocity? The difference between speed and velocity is that while speed is a scalar quantity, velocity is what? A vector quantity. And I believe you understand what they mean by a scalar quantity and a vector quantity. The scalar quantity, I've already explained that a scalar quantity is that quantity that has magnitude, but it does not have direction. Okay, while vector quantities on the other hand, they have both magnitude and they also have what? They also have direction. So they are specified by their direction and their magnitude. So when that is vector quantities. Now, why scalar quantities are only specified by their magnitude alone. And when we talk about magnitude, we are talking about numerical value. For instance, temperature. Temperature is a scalar quantity. We cannot, ascertain the direction of temperature. The only thing we only know is the magnitude. I can say a body is 20 degrees Celsius or 35 Kelvin. That is the only thing I can say. We cannot specify the direction. There's no direction when we talk about temperature. So that's all those temperature and those things that don't have direction, those quantities with no direction, they are known as scalar quantities. Why the ones with direction? For instance, like velocity now, it has direction. So we can say velocity is what? A vector quantity. While speed is what? A body can just have a certain value for speed, but there's no direction. Velocity, if I'm getting the velocity of a moving object, if it's velocity, I will specify the direction. I can say this body is moving at a speed of 20 kilometers per hour in so and so direction. Because of that direction I have already included, it's no longer, it's not just speed now, it is now velocity because of the direction involved. But if there's no direction, it is just a mere speed. Okay, magnitude, no direction, that is scalar. Why the one with direction is what? The vector quantity. So take note, speed equals to distance over time, and velocity equals to what? Displacement over time. And another one is acceleration. Acceleration is now change in velocity over time. Delta V, change in velocity over time. Okay, change in velocity simply means if you talk about change, delta, if you say change in a body, change in something, it means there is initial and there is final. So if we say change in V, change in velocity, it means there is initial velocity and there is final velocity. Okay, so change in V would now be what? Final velocity minus initial velocity. For instance, if the price of this marker I'm holding, if the price of this marker initially was 15 naira, okay, and then due to inflation, and then the price has risen to 100 naira, the initial price of this, that means before it rose, what was the initial price? 15 naira, right? Then after it has risen, what it's now the final price? 100 naira. So it means the final price 100 naira. If I'm looking for the change in price of this, change in the cost of this, it will now be final minus initial, that is 100 naira minus 50 naira. The same thing here. Change in V. Listen, in physics we usually use V to represent the final velocity and U to represent the initial velocity. Anyway, you see U, it means initial velocity. So if I'm rewriting the formula of acceleration will now be what? V, final velocity, minus what? U, which is standing for initial velocity, over time. That is acceleration for you. Final velocity minus what? Initial velocity. So remember this A. Acceleration equals to V minus U over what? T. If I cross multiply, I have V minus U to be equal to what? AT. Okay, V minus U to be equal to our AT. So if I move this U to the other side, I have V to be equal to U plus AT. Please, this is one of the equations of motion. Take note of it. This is how they derived it. one of the equations of motion. We have three major equations of motion. You have three major equations of motion. You have V minus equals to U plus AT. You have another one, S equals to UT plus 1 over 2 AT squared. And you have another one which is V squared equals to U squared plus 2AS. These are the three major equations of motion. You see this first one, this was how they derived the first one from acceleration, from your definition of acceleration. That was what bettered this equation of motion. Okay, and this is it. And you have seen how I did it. It's not hard. I just brought out the formula for acceleration. Acceleration equals to what? Change in velocity. That is V minus U over time taken. If you cross multiply, you have it to be 80. V minus U, this is over 1. V minus U multiplied by 1 will give you V minus U equals to what? T times A will give you what? AT. If you move the U to the other side, you have it to be U plus AT. V equals to U plus AT. That's how they got that equation, first equation of motion. Okay? That's that for that. So please take note of this. Remember, our unit of acceleration is meter per second square. Or you can write it like this, meter, either like this or like this, whichever way you want to write it is correct. Meter per second square. That is the unit. Plus, take note of this. Now, under this acceleration, there is an acceleration has opposite. If you have heard of deceleration, okay, deceleration is the opposite of acceleration. Deceleration is the opposite of acceleration. Okay, if a body is decelerating, it means the body is coming to rest. You know, let's say a moving vehicle, you know, that is on a high speed. You know, when it applies the brake, after some time, the moving vehicle will come to rest. In other words, it will gradually stop moving. Gradually, that moment where it is gradually coming to rest, you know, that moment, that is what called, you can say that the body is decelerating. At the time why it was, you know, increasing its speed and then it's on a high speed, we can say it is accelerating. But now that it is coming to rest, we can say it is decelerating. So acceleration and deceleration, they are opposite. Now listen, acceleration of a body and deceleration of a body, most time they can have the same value but different, you know, direction. Why decelerating is going up, why accelerating is going up, decelerating is coming down. So it means that if the acceleration of a body, another thing you need to note about deceleration is that it is always negative. So if I say acceleration of a body is -2, it means the body actually decelerated. It decelerated. Are you with me now? It's decelerated. Okay. Now let's take some problems. Let's just solve like 2-3 examples, then you will understand this concept better. Okay, now pay attention to this question. It said a car travels at an average speed of 100 km per hour. Please always take note of these units, okay? 100 km per hour. It said what distance does it cover in 5 minutes? So you see the parameters given to us, where we know they gave us time, they gave us kilometer per hour, the speed, they give us speed. Remember the formula for speed. Speed equals to distance over time. Okay, take note of this formula. Speed is equals to distance over time. So from what we have, they gave us speed to be equals to 100 km per hour. And then what other, they give us time to be equals to 5 minutes. Now you see this minutes. Now I will not leave this 5 minutes like this, because if you compare with this place is hour, this one is in hour, this one is in minutes. Okay, first of all, since the both of them are talking about time, it is wisdom, or it is better that I convert this 5 minutes to hour, so that to align with this hour here. That's how you know how to convert. Now this conversion in physics, you know, is something that usually confuses many students. They don't know when to convert. You convert to make the unit align. Okay, now look at this. Now I cannot work with hour and minute. No, it's either I am using minutes, either I'm converting this one to minutes, or I come and leave this one in minutes, or I convert this one to hour, so that to align with this. So I think it is better I convert this 5 minutes to hour. So if I'm converting 5 minutes, if I'm converting 5 minutes to hour now, what will be the answer? What am I supposed to do? If 60 minutes make 1 hour, then 5 minutes will now be how many hours? So all I need to do is just to divide. It means 5 minutes will now be what? Look at it here. 60 minutes is equivalent to 1 hour. Then we have 5 minutes. How many hours? I don't know. I can say x. So if you cross multiply, you have 60x equals to 5 times 1 is what? 5. Divide both side by 60. Divide by 60. This cancel this. So our x is equals to what? 5 over 60. And if you reduce it, 5 over 60 is still the same as 5 here 1. 5 into 60, I think it's 12 or so. Yes, 5 into 60, so I don't know, 1 remain 1. Yes, that is 12. So it means this time, if I convert it to hour, it becomes 1 over 12 hour. So this is what I will use instead in my calculation. So distance is what they say I should find. I don't know. So but our speed is equal to distance over time. So substitute. Wherever you see speed, put this value. Speed is 100. So you put 100 equals to distance. That is what they said I should find. I don't know. Let me use it to represent it. What about our time? Time taken is what? 1 over 12. So I can say divide by 1 over 12. So this becomes 100 equals to D divided by 1 over 12. So I have this to be equals to 100 equals to D times, this becomes times, right? 12 goes up, 1 comes down. 12 over 1. So this becomes 100 equals to 12D. Divide both by 12, divide by 12. This 12 cancel this 12. So our D equals to what? 100 divided by 12 gives us what? If you reduce this, it gives us 4 can go here, 4 can go here. 4 into 100 gives us 25 over 4 into 12 will give us 3. So we have it to be 25 over 3. If you can press your calculator and get your answer in decimal, that's better. That's fine. So our distance is what? 25 over what? Over 3. What will now be the unit? We can get the unit from this place. See, this place they use kilometer. So it means I will leave my answer as what? Kilometer. So you can see this question. I already changed the question. This is example 2. So I want you to solve this one yourself and drop the answer at the comment section if you actually understand the previous example I solved. So you do this one yourself and drop your answer. It says a car travels at an average speed of 150 km per hour. What distance does it cover in 30 minutes? Drop your answer at the comment section. Okay, quickly, let's look at example 3. They said a car moves from a velocity of this to a velocity of 30 meters per second. From a velocity of 20 meters per second to a velocity of 30 meters per second in 5 minutes. And the question is calculate its acceleration. Remember acceleration. Don't forget acceleration equals the change in velocity, that is v minus u over t. Don't forget these formulas I've told you before, because you would find them very helpful in dealing with problems like this. So acceleration from our problem, our question, we know they said from 20 meters per second towards 30 meters per second. So it is obvious this is the first velocity. It started from with this velocity and ended with this velocity. So it means our initial velocity is 20 meters per second, and v, our final velocity is what? 30 meters per second. What is the time taken? Time is what? 5 seconds. Now, if you notice, I don't need to do any conversion here. Why? Because the time is already in seconds. So everything is aligned. 20 meters per second, 30 per second. This one is what? 5 seconds. Assuming this is in minutes or in hour, I would have to convert it to seconds before I will start calculating. So this question is just direct. Just go straight to the formula. Apply the formula. Our acceleration equals to v. What is the value of v? Which is 30. V is 30. And minus, what about u? And u is 20 all over time. Time is 5. Time is 5. So if you solve this, if you subtract this, it gives us 10 over 5. So our acceleration is 10 divided by 5, so 2. You will not leave the 2 like that. You have to put the unit. If you put the unit, you have to be meter per second square. That is the unit of acceleration. I've told you that before. 2 meters per second square. So if you understand what I just solved, so you solve your own now. You solve example 4, and then let's assume this is our 40, and this is 10. 10 seconds, and this is still leave this one as 20. You solve yours and drop your answer at the comment section.